A very good morning to all of you. Today we are going to start our fifth day of FDP. Every day is a good chance to learn something new, to grow stronger, and to move one step closer to your goals. As we begin the fifth and final day of our FDP on sustainable construction practices in civil engineering, let's take a moment and appreciate this wonderful journey of learning. Today, we are honored to welcome highly experienced professional Mr. Pradip Jha, who is currently the Zonal Head Technical and Customer Solution at Ultratech Cement. Mr. Jha holds a degree of civil engineering from Tribhuvan University and an MBA from Bangalore University. With over 20 years of experience, he has worked in a building construction, hydropower projects, cement marketing, and customer relationship. So let's us extend a warm welcome to Mr. Pradip Jha. Sir, over to you.
Thank you, ma'am. Am I audible?
Yes, sir, you are audible.
Okay. Is the screen visible? Is the screen visible? Am I audible?
Yes, sir, you are audible. And my screen is visible.
Yeah. So thank you. I think it's a wonderful platform, having all learned people all around. So whatever I'm going to share is just through the practical exposure that we have experienced in the last 20 years of corporate exposure. And I have been associated with Ultratech, but of course, today we are not merely a cement manufacturing company. Today we are into entire building solutions and building materials industry as a whole. So as we transition into a building solutions journey, we come across different building materials, different building practices that are intended to be sustainable, that are intended to build to green construction. And today, when we speak about sustainability, we obviously speak about SDGs, that is Sustainability Development Goals. We have net carbon neutrality, and other keywords as well. So as we deep dive into the topic, I won't be going much deeper, but whatever we have in the industry, whatever facts and figures we have across the years, that is what I'm going to present. So there may be some alterations, but of course, this is what the trend is today. So the topic that we are going to speak on is sustainable construction practices in civil engineering. So of course, sustainability is a very, very wider term, and every action that we do, every thing that we put into place has some angle of greener, some angle of environment, some impact on the surroundings that we live in. So how, as a civil engineer, we can do a little bit that adds to the greener construction, that adds to the sustainable construction. That is what I'm going to highlight today. So this is basically what is sustainable construction. So if you see any construction that we do, and if it is resource efficient, either in its design, so when we design any construction, and if it is resource efficient, when we construct anything, and if it is resource efficient, or when we dwell into it, when we start using it, or when the construction or structure is into operation, and if it is resource efficient. Once the normal life cycle is over, then the maintenance comes into picture. And even during the maintenance period, if my construction is resource efficient, during my renovation stage, if it is resource efficient, or finally, when the structure has done its life cycle and we have to demolish it, even then it has to be resource efficient. Only then that the construction can be said sustainable construction. So when we say sustainable construction, the construction should be able to reduce negative impacts on our climate and natural environment, or eliminate the negative impacts on our climate and natural environment. Of course, when we speak of sustainable development, sustainable construction, it has to create a positive impact on our climate, on the surroundings that we live in, and on the natural environment as well. Any construction can be sustainable, whether it is a building, it is roads, whether we speak of canals or metros or airports, whatever construction we do, it can be sustainable. But it is not necessary that all the construction that we do has to be sustainable. So that is the key point. The third point is, the sustainability is very subjective. So what is sustainable in Northeast may not be sustainable in the coastal areas. What is sustainable in India may not be sustainable in any other part of the world as well. So every part of the world has distinctive climatic conditions. They have unique cultures, their traditions are different, and their construction types are very different. Their exposure to environment is very different. Their economical and social priorities are different. And that is how sustainability gets impacted when we change locations and when we change places. These are the basic principles of sustainable construction. So whenever we speak of sustainable construction, the prime motto is that it has to have a very positive impact on environment. Of course, when we say the natural resources that we use for sustainable construction has to be efficiently used, very judiciously used. And if we can make use of resources very efficiently, it culminates into sustainable construction. When we speak of sustainable construction, we have to speak of life cycle approach. So when we design, it has to be sustainable in our mind. When we construct, it has to have sustainability factor crept into it. When we are operating with those structures, when we start living with those structures and construction, it has to be sustainable. So from design to demolition, every stage of the life cycle, it has to be sustainable. Finally, the ones who are using it, the surroundings, it has to have sustainable construction needs to promote health and well-being of the occupants as well. So when you build a green building, when you build sustainable roads, so whoever the users are, the health being, the wealth, the well-being and the safety comes into paramount importance. So these are the triple bottom lines. So this can't be negotiated. So when we speak of sustainable construction, it has to reduce waste, it has to reduce emissions, and that is how environmentally it has to have positive impact. In long run, if it is not economical, it doesn't make sense. So when we say any sustainability, it has to be socio-economical. The social economical means the social, it implies the social structure, the quality of life of the society, the health and safety of the occupants. And economical, of course, it has to have some sort of savings. And so savings can be in terms of many factors as well. So these are the three bottom lines: environmental and social and economical. So these three bottom lines has to be considered when we speak of sustainable construction. Now, since we are civil engineers, we are into construction industry. And what is the impact that construction industry is doing to the environment today? Let us have a look at it. So there is a forum called World Watch Institute. And if you see, this forum says the construction industry consumes 40% of the world's raw stones and gravel and sand. The construction industry consumes 25% of the virgin wood per year. Similarly, if we say for energy-related emissions and carbon dioxide emissions, the construction industry, construction sector is responsible for 39%. That is very huge. And whatever the waste is produced, 59% of the waste is construction and demolition waste. This is what World Watch Institute says. The other research by Clayworks, it says that whatever fresh water we have, 16% of the global fresh water consumption is being done by these construction activities. So that's very huge. When we are deprived of fresh drinking water, 16% goes to construction activities. 25% goes to wood consumption, and of course 25% goes to global waste. Now, this is a construction block, beam hall, and it says that whatever air pollution we have, 23% comes from construction sector. The climatic change, construction sector contributes to 15% of the climatic change. Drinking water pollution again 40%, and landfill waste is 50%. Again, if we say this is what, just a minute, I think I have. Is my screen visible?
Yes, sir.
Where my screen has gone? I'll just reshare again. I think it's visible now.
No, sir. Now it's visible, sir.
Visible, no?
Construction industry.
Again, the US Green Building Council says the construction industry accounts for 40% of the worldwide energy usage. And it is going to grow up every year by 1.8%. Now, we are into cement industry, and of course, cement industry contributes a lot to the construction. So let us have just a perspective from cement industry. India has an installed capacity of 590 million tons. The world has almost 4.2 billion tons. We are the second largest cement producer in the world, after China, of course, and we contribute to 7% of the global installed capacity. Our per capita cement consumption, if you see, is only 250 to 270 kgs, whereas the global average is 500 to 550 kgs. And China accounts to 1750 kgs. If you see the budget every year, there is a huge allocation for construction activities by the government. Housing is one of the sectors, affordable housing is one of the sectors. So housing for all is Pradhan Mantri Awas Yojana urban. Similarly, you have Pradhan Mantri Awas Yojana rural as well, and huge amount is laid on this. And we all know for every ton of cement that is produced, 1 ton of greenhouse gases emissions is released. Also for every ton of cement that we produce, around 6100 megajoule of energy is released. So that is what the amount of cement is energy consuming and also resource consuming. If you see, there are many improvisations in cement manufacturing. So when you see supplementary cementitious materials, the industrial byproducts which have cementitious properties, those materials are being used, and fly ash is one of those. So if you see, around 58 million tons of fly ash was used, and if you see the contribution of slag in cement production, it has now increased to 57%. We have many slag cement, we have composite cement amendment number 1. So those cement, they use fly ash and slag as well. If you say PPC, it is only fly ash based. So these two blended cements make use of industrial byproducts for the betterment of the environment, for making cement greener. Now, if you say where does the cement go? If you see rural housing, 29% of the cement that goes is into rural housing, 25% goes into urban housing, and mass housing, if you say, that is 12%. So in housing sector alone, around 66% of the cement is getting used. Apart from that, there are commercial buildings and infrastructure projects as well. Now, when we spoke of cement, we say concrete. Concrete is the second largest material used, and every construction that we think of comprises of concrete. So this is the scope of concrete that you can see, and it's very, very huge. See, this is just a context setting of why sustainability in civil engineering. So if you see concrete today, there are a lot many concrete coming into picture. There is precast concrete, there are value-added concrete, and the concrete industry is getting bigger and bigger. So if you see concrete production and everything, it is getting very, very huge. And later on in the slides also, we'll see the volume that is coming to picture. And there are different types of concrete that we produce that we want to have in our structures. So it could be precast concrete, it could be concrete over bridges, it could be concrete in a modular shape, it could be concrete in a very entirely aesthetical look as well. Now, of course, water is again one of the prominent ingredients that is being used for construction. And if we speak of sustainability, we can't ignore water. So if you see in the next 15 years, India will witness around 30 billion meter square of construction area in urban area alone. RMC plants in India, they normally produce 100 to 120 million cubic meter of concrete per annum. Now, this is only 10% of the concrete that we use. So if we say the concrete, of course, it must be around 1,000 to 1,200 million cubic meter of concrete per annum. And for these RMC plants, we require 35 to 42 billion liters of water. So for 100 to 120 million cubic meter of concrete, we require 35 to 42 billion liters of water per annum. So if you see, total water requirement in concrete alone in India is 350 to 420 billion liters per annum. This is only for making concrete in RMC and making concrete. Now, we all know that we require water for curing of our construction as well. I am speaking only of curing of concrete, and that is around 18 to 30 billion liters per annum that will be required in the next 15 years. So this is the amount of water that we are using for construction every year. So there were three things that I wanted to bring here. One is cement, one is concrete, the other is water in concrete. And these are very startling. Now, so I'll be focusing more on, when I speak of sustainable construction, I'll be speaking more on green products and materials. So when I say green products and materials, obviously cement is one of those. Concrete today is a product itself. And there are not many building products that have come into picture, and I'll be speaking on that as well. The second part would be green practices. What are the practices that make my construction green and sustainable? So one is rainwater harvesting, the other is solar energy, then energy efficient designs, and of course, construction demolition waste is one of them. Finally, we'll also speak of green buildings, because buildings are one component of sustainable construction. And how do we promote the IGBC certification in different categories? By green cement, what we say is the cement which is produced with reduced process energy. So I've already said 1 ton of cement, if we want to produce 1 ton of cement, it requires 6100 megajoule of energy. It releases about around 0.8 to 1 tons of CO2 into the atmosphere. So green cement is a cement which has low carbon footprint, which is composed of recycled and renewable resources, which have minimal environmental impact. So if you say, you'll get an idea what we mean to say. We say that when you use blended materials, when you use blended cement, when you use supplementary cementitious materials, when you use alternative source of fuel, you make green cement. So Ultratech alone produces different type of cement. We produce PPC, we produce PSC, we produce composite, and you can see the amount of CO2 reduction that we do in different type of cement. Now, why we say Ultratech cement is a green cement? Because we are 5x water positive. That means whatever water we consume in producing cement, we conserve 5 times more than that. We reuse, we recycle the waters 5 times whatever we use. Sorry, this is plastic negative. So when I say plastic, what happened? This plastic negative. So we don't produce plastic, but we use plastic as fuel material and every other things that we use. That is why we are 2.8x plastic negative. Now I'll tell you what is the amount of water that we contribute to the society. Every year we preserve, we harvest 7,100 crore liters of water. And what does that water amount to? For the entire population of Delhi, whatever the drinking water they require for 7 months, this 7,100 crore liters of water is sufficient. Similarly, we reduce carbon dioxide emissions to the tune of 12 millions. And what does that amount to? Entire Bangalore vehicular pollution, whatever emission they do for 19 months, we reduce that emission every year, every 12 months. Now, we are energy sensitive, we are very energy efficient, and for that we have waste heat recovery systems in place. We have renewable energy in place, use of renewable energy in place. We make use of alternate fuels, and we have alternative raw materials as well. That is why we say we are green cement. Today, whatever cement we produce, 70% of the cement is green cement. Again, I'm speaking of concrete. So when I speak of concrete, I say ready-mix concrete. And ready-mix concrete is green concrete. Why? Because obviously it makes use of efficient resources. So when you ready-mix concrete are normally designed concrete. So you put into place concrete mix design principles, and that is how you optimize the resources that you use. Secondly, you recycle wastewater and you use that water there. Third, the aggregates, of course, at times you recycle aggregates and then you use it. You make use of supplementary cementitious materials, and that is engineered. And also, the noise pollution, the dust pollution at construction site gets reduced. So that is how ready-mix concrete is green concrete. Now, this is again, why I'm saying is, obviously, as civil engineers, when we are commuting, we see many transit mixers on roads. That is an indicator that today ready-mix concrete is gaining pace very quickly. It is gaining acceptability in a wider way. It is gaining acceptability from all the corners. Initially, only institutional customers used to make use of ready-mix concrete. Today, even a normal house builder, a normal citizen, when they want to make a house, they ask for ready-mix concrete. So this market is getting huge. And you can see in billions what the size of ready-mix concrete is growing day by day, month by month, and how it intends to go ahead. So in 2032, 7 years down the line, it says it would be a market of $1,206 billion. And it is being used in commercial, infrastructure, residential, industrial utilities, and lot many. So when we say ready-mix concrete, there is one concrete. If it is of course not only ready-mix concrete. Concrete normally we say it is against the environment, but we saw what is the importance of water, why the water needs to be preserved, why the groundwater should be prevented from depleting, and that is where this pervious concrete comes into picture. So we design concrete to let water go inside. So whenever you want to design your patios, your walkways, pathways, you make pervious concrete so that it suffices the need of concrete, and simultaneously it allows the groundwater surface water to percolate inside the land, local land, and avoiding any depletion of groundwater table. So I'm not going into technicalities, but this concrete is designed to let water permeate in the ground. A small video.
Stormwater runoff occurs when rain falls in urban areas. This runoff can cause increased pollution in rivers and streams, flash floods, and loss of rainwater that replenishes the water table and aquifers. By capturing rainwater and allowing it to seep into the ground, pervious concrete is instrumental in recharging groundwater and reducing stormwater runoff. Pervious concrete is a carefully controlled mixture of mainly coarse aggregate, cementing materials, and water. The reduced sand content results in a pavement with a high void content, allowing water to pass freely through it, putting rainwater back where it belongs, in the ground. Pervious concrete has a 15 to 25% void structure, and flow rates of 200 liters of water per minute for each square meter of pervious pavement are typical. Pervious concrete is a durable material. It has been used for low-volume streets, driveways, sidewalks, and parking lots throughout the Pacific Northwest. Pervious concrete has also been used in freeze-thaw conditions for over 15 years, and technical and design expertise is available to ensure optimal performance in freeze-thaw applications. Pervious pavement is a best management practice recommended by the U.S. Environmental Protection Agency.
The second in line is self-compacting concrete. As we all know, this concrete, normally we add much more water at site, which is not desired. And this is a concrete that makes use of viscosity modifying agents and of course high range water reducers to make this concrete. And this is how it makes durable concrete. Helps us. This is an example of self-compacting concrete. So if you see, the noise pollution is very less, the use of water is less, so we have sufficient workability and pumpability. The use of machines, the use of resources are very less.
M30 होगा सर
जल्दी लेके आ जल्दी अबे बांध लेते आना 45 का 45 का पेड़ ले ला 45 के अबे बांध ले ला 45 का लेके आ का बेटा मेरा आगे देख रहा
Now, we spoke of cement, we spoke of concrete, we spoke of two special concrete, that is pervious concrete and self-compacting concrete. Now, there are certain products in the market, and those products are Green Pro certified products. So, whenever a product suffices the parameters of this Green Pro certification, they get this Green Pro certification as well. So we have building blocks. Normally, conventionally, we have been using clay bricks and other bricks as well. So today we make use of AAC blocks. So AAC blocks, if you see, they require less of, they don't require soaking of AAC blocks. While in normal conventional clay bricks, we require soaking of bricks. So that is where you save water. These blocks, AAC blocks, have a great precision. These blocks, we can cut these blocks through our hacksaw, so the waste is very less and optimal use of materials can be there. The second is we have these dry mortars, dry jointing mortars. These mortars don't require curing. to much extent. So normally, whenever we do a construction, we require a minimum of 10 days of curing. With these dry jointing mortars, you require only 1 to 2 days of curing, and you get sufficient strength. Similarly, for plastering mortars, today we have many plastering mortars, do-it-yourself product, and it is available in the market under the name of Ready Plast for Ultratech. The rebound loss is very less. Normally, the plaster, you waste a lot of material in rebound, so that is very less. If you use this mortar in AC blocks, the consumption of this mortar is again very less compared to the conventional mortar, and the curing is also requirement is also very less. Now the third part is normally today there is a lot of tiling works in progress, and if you see when we do conventional tiling works, we make use of many natural resources. The conventional mortar is very thick, and of course it is not very durable, and it doesn't have longevity as well. So today when we have tile fixos or other adhesives, those adhesives are very thin, so your material requirement is very less, and apart from that, it is very sturdy as well. Apart from this, of course, we have waterproofing systems, and that waterproofing systems, if you see, it works on optimization of water content, and that is how these products are Green Pro certified specialist products. Similarly, ready-mix concrete solutions, I said we have many products, and there are names that Environment Plus and other cement concrete as well. We have Free Flow Plus, that is self-compacting concrete. Dura Plus is durability, and lightweight concrete, pervious concrete. So these concrete are durable, but they are very environment friendly as well. So these are Green Pro certified products because they are made in such a way that it rises to the environment. Now, construction practices, of course, today civil engineering, you see many houses, solar panels are being installed, and rainwater harvesting is being done. We know rainwater harvesting has a huge scope, and today every design a civil engineer does, architect does, they have to put rainwater harvesting systems into place. Else, the authority doesn't approve those plans for construction. Barring this, if you go to the market, there are many faucets, appliances, gadgets which have rating, energy efficient rating, which are the faucets that use less water, that are environment friendly, that are very much eco-friendly. The energy consuming appliances which save energy and which save money from your pocket in a longer run. So those green appliances, those faucets are also abundantly in the market today. Now we spoke of everything, but now 2-3 slides will be speaking on green buildings only. So green buildings, when we say the green buildings again are based on the concept of it conserves natural resources, it uses less water in operation, it optimizes energy efficiency. So whatever energy we make use in our houses, it has to optimize that. It has to generate less waste, and it has to provide healthier spaces. This is the environmental benefits for every 1 billion square feet of green building that we make. So every 1 billion square feet of green building that we make, the carbon dioxide emission is reduced by 12 million tons. Every 1 billion square feet green building that we make, we save 15,000 gigawatt of energy. And every 1 billion square feet of green building that we make, we save 45 million liters of water. And the source of these facts is Indian Green Building Council, an authority in green building. So green buildings has economic benefits, it has environmental benefits, it has social benefits. If you see social benefits, you see the workers who work in green buildings when ventilated offices, they have 101% increase in cognitive scores. They have a very good quality of sleep. If you see their performance, it has increased up to 8%. Environmentally, of course, and energy saving, if you say, they can save 40 to 50% of energy, and they can save water to the tune of 20 to 30% compared to whatever conventional buildings that we make. normally it is seen that if you make green buildings, your asset value is increased. People tend to rent such buildings which are green. And how do we make it? We minimize waste, we maximize reuse. And of course, if you see, green buildings are very good for the health of the occupants, because fresh air, natural light, natural views, designed for your acoustically designed for ears and eyes. So these are the things that helps green buildings make productive and better efficient society. Again, green building is based on considering all stages of building's life cycle. So from design to construction to operation, maintenance, renovation, and eventually demolition. This is one concept. So see, we have seen this. If you go to any city, especially Rajasthan, where erstwhile the Maharajas were there, those Havelis, those forts have been converted to restaurants. Those forts have been converted to big hotels. So this is what adaptive reuse means. And when you see, rather than demolishing those structures, those have been made to be reused, adapted to be reused. And that is how you avoid demolition, waste. That is how you avoid wastage of resources as well. So you don't need to make new construction. You limit the waste generation. You preserve your historical and cultural heritage, whereas you revitalize the communities, the older, whatever you say, our historical monuments, and we make use of that. This is one of the assets, the fact. Now, these are some of the authorities which are into green building certification. So it is IGBC, it is ASRAI, it is BREEAM, it is LEED. So these are the institutions that help you certify green building, and that helps in sustainable construction as a whole. Now, we at Ultratech also partners with lot many people who want to have their homes green building certified. So for normal home builders, there are two certifications. One is IGBC Nest, the other is IGBC Nest Plus. And Ultratech Cement partners with IGBC and the normal house builders in getting those houses certified if their houses meet the parameters of IGBC certification. And we have done a lot many. I think this is what I had to offer. So when we speak of sustainable construction, we speak of energy efficiency, we speak of eco-friendliness, we speak of green cement, we speak of green concrete, we speak of durability, we speak of creating a sustainable future, we speak of being water positive, we speak of lowest carbon footprint, and lot many other things. That is what I have to say. Thank you from my side.
Imagine waking up every morning in a house that can breathe and knows how to take care of you and your family. This was the dream of 36-year-old Varun Sharma. Varun, who struggled in the city full of traffic and noise and often thought he didn't have any choice. But one fine day in the same city, Varun and his family saw his dream house. This was his colleague Sudhir Mishra's house, which, although located in the city, seemed to be different. Sudhir had his own reasons to build such a house. Carbon pollution. Every year in India, around 2.6 billion metric tons of carbon dioxide is getting emitted in our environment, and any city home emits around 6,000 kgs. Power crisis. Every city dweller is struggling with increasing electricity bills and the power cuts. Water crisis. Water sources are limited, but the population is increasing at a rapid rate. Poor waste management. A normal city home has no means of disposing its own household trash. But Sudhir's home was an answer to all these problems, because it was a green home. Green homes are homes that are designed to be eco-friendly. A green home uses clean solar energy to generate electricity. A green home, by its natural lighting and ventilation system, keeps the house full of light and enhances the indoor environment quality. Special rooftop gardens in a green home ensures better insulation and cooler homes. And residents' water requirements are ensured by an effective rainwater harvesting system. Varun realized now that building a green home isn't just his dream, but also his responsibility for the well-being of the environment and his family. What Varun required was an expert, and that expert came in the form of the Ultratech app by Ultratech. Ultratech, which has developed a unique one-stop solution platform to provide all the necessary resources, guidance, and information to build a green home. With every small step, Ultratech and Varun systematically moved towards achieving a sustainable green home, which started with choosing the right location to build a new home, preserving the nutrient-rich topsoil, and later reusing it for landscaping, building a water harvesting system to ensure 1,000 liters of rainwater for every 1,000 square feet area of the house, installing solar panels and solar water heaters for the households, and check-marking all the rules and guidelines of the IGBC checklist. Varun could now see a significant difference in his new home as compared to his earlier conventional city home, like the use of certified green construction materials, energy-efficient fly ash bricks, blended cement, and eco-friendly VOC-free paints, tinted windows with sunshades to keep the house warmer in the winters and cooler in the summers. Energy-efficient electronic appliances were installed. To shield the house from intense sunlight, white-colored tiles and reflective paints were used on the roofs and the walls. 2 separate boxes were introduced for disposing organic and non-organic waste and a compost pit for an easy disposal of the domestic waste. With UTech's assistance, Varun and his family turned their green home dream into a reality. And as a recognition of their effort, they were awarded the Green Home Owner Certificate by the IGBC. For the Sharma family, the green home benefits continued to accumulate. Within just 1 year, Varun saved 30% of his electricity and 50% of his water bills. Also, the value of Varun's green home increased significantly as compared to any traditional city house. Varun's and Sudhir's green homes are not just homes, but also a natural protective shield for each home dweller, providing a clean, healthy, and joyful living environment to all. So if you wish to build a new home, then Green Home will guarantee you lesser electricity bills, lesser water bills, lesser maintenance cost, eco-friendly, and a promise for a healthy and happy living. Scan the code to download the UTech app and get full guidance for your beautiful green home today. Green Home, a perfect gift of love for this planet and your loved ones.
Thank you.
Thank you, sir. Thank you so much for this wonderful session. We are very thankful how green concrete and helps in as a storm water management and different sustainable material. So very thankful, sir, for a wonderful session. We have enjoyed a lot
Thank you
through
very much.
slides and through videos. As we come to the close of this enriching week, I extend my heartful thanks to all the participants for your active involvement throughout the program. A special thanks to all the speakers who gave such a knowledge about during the FDP program. We are also deeply grateful to all our expert speakers. Let us continue to apply what we have learned and move forward with a strong commitment to sustainable development. The future depends on what we today. So best way to predict the future is to create sustainability. So whole FTP we have learned about so much sustainable materials, sustainable concrete, sustainability, how we apply sustainable things on our civil engineering. So hope you all are enjoy this session. Participant, please turn on the cameras, please, for a group photo. Turn on the camera, please. Thank you, sir. Thank you. Thank you once again. Wishing you all the success ahead. Certificates will be issued within 10 days to all the participants. We'll communicate through WhatsApp group only. Any participant has any query, do let us know in chat box, or raise your hand. Thank you. And kindly fill the attendance sheet so that we could make our certificates. Yes, sir. Uh, Jigadeshwar. Wait. Sir, you can write on the chat box if you have any query. Okay, we'll share, sir. I- Sir, you can text on WhatsApp group behalf of this, na? Oh, thank you all the participants.